Good night. As we continue with our periodic table and giving a little focus on some specialized focus on elements, just to the Professor Dr. Dolphy Gilpin here, and we are at the 14th element, which is silicon. Okay, so we go to our deck of cards because we have about 25 elements in this pack here. And we have found silicon right on the top. No need to search. Okay. Silicon, atomic number 14, and atomic mass of about 28.1. Both sides we have atomic number 14 and atomic mass of 28.1. Its electronic configuration is neon 3s2 3p2. That is neon 3s2 3p2. 14. And here we have our little book with that have written with notes, handwritten notes. And we'll look at our notes, then we'll go to our periodic table and highlight it. So here we have from our notes, silicon. Let's say a semiconductor. The first thing that comes to mind is that silicon is a semiconductor and it's widely used in electronics device, computer device, transistors, high speed and medium speed transistors, although we have a competition with it with gallium nitride, which have some higher speed electronics device. But let's just look at silicon here. But that's the first thing that comes. We know we have used it very much in electrical engineering. We did silicon wafers in these devices. A separate course in our electrical engineering curriculum called semiconductor. like 444 was the name of the course. Semiconductor with wafers and silicon, and we know straight off that silicon is so important to us that there's a place named for it in California called Silicon Valley. Called those silicon engineers, specialized in silicon and the uses of silicon to make these devices, computer chips, solar cells, and things like that. All right, silicon. Okay, from our note, silicon, we have given atomic number 14, atomic mass 28.084, neon 3s2, 3p2, a solid at room temperature, a semiconductor, metallic luster, brittle, melting point 1140 degrees centigrade, boiling point 3265 degrees centigrade, density 2.33 grams per cm cube, oxidation state of -4, +2, and +4. It simultaneously conduct electricity, and it's also an insulator, and that's why it has this property to be used in these semiconductor wafers. It's not too much of a good conductor of electricity, but it conducts electricity, and it's also used as an insulator. The electronics property of silicon is that it can be modified via a process called doping to make transistors, and these transistors can amplify electrical signals. Its abundantness in nature, it's very abundant in nature, and that makes it very appealing. Because of this abundantness or the abundance, it makes it relatively less expensive than other metal, since it is so plentiful in nature. And the Earth's crust, I think it's about the seventh abundant nature in the universe, and about the second abundant nature in the Earth crust. It's extremely affordable, and it's the basis of memory chips, computer processors, transistors, and other electronic devices. And we have the other element that gives it some competition is gallium nitride, and these are faster electronic movements, and so give faster electronic devices. Okay, let's go on to some more properties and characteristics of silicon and uses of silicon. Turn to our book here. A little back here. Yes, said without silicon and silicon wafers, the electronic industry would be intangible. Some of these devices that we know of in smartphones, in computers, transistors and things, they would be not available, otherwise intangible. So that's the importance of these silicon wafers in making these electronic devices and computer accessories. And as I said, that one of the trip to the moon, that they left some silicon wafers, silicon thing behind the moon in 1969. That's what they said. It's alleged. I've said here. Silicon is there's a difference between the silicon and the silicone. That silicon is a natural element with atomic number 14 and atomic mass of about 28 point something, while silicone is a man-made from silicon. It's a man-made compounds from silicon. It might be said that they might have some silicon-based life. That is one probability or possibility that they're saying that the silicon property or characteristics that they might be basis for silicon-based life as they are basis for carbon-based life. It's the seventh most abundant element in the universe and the second most abundant element in the earth. I think I've also mentioned that before. And in biology, we could have the carbon and the silicon combining. And what you have, silicon dioxide. What's that? Silicon dioxide, that's like silica sand and all of that. We find silicon dioxide in glass. The most porous form of silicon is a quartz. Although we have silicon can be found in other things like olivine, pyroxene, even in water. It can be found on the beach there in the dirty sand, silicon. Can be found in the fire bricks, and it is found in Portland cement. And silicon carbide is used to make lasers. Sodium silicate, NaSiO3, is known as water glass, and it's used in the production of soap. Silicon carbide is used in, it's very hard, like diamond, and it's used as an abrasive. Whereas silicon tetrachloride is used to make smoke screen. Now silicon react with a lot of elements under different conditions of temperature and pressure, different reacting condition. It does react with a lot of other elements. Silicon form stable covalent bonds with carbon, nitrogen, and sulfur, phosphorus. It forms compound with halogens family and also with metal germanium. Silicon is a metalloid, neither a metal or a non-metal, but somewhere in between a metal and a non-metal, and have this sort of metal, non-metal properties, like in between both. It does not react with acid readily, and it's dissolved in hydrofluoric acid. Does not react with the acid on the normal condition, but will react with hydrofluoric or dissolve in hydrofluoric acid. And silica melt at about 3110 degrees Fahrenheit, 1700 degrees, 1710 degrees centigrade. And the main constituent is flat glass. The main constituent of flat glass is silicon oxide or silica sand. It has a melting point of 110 degrees centigrade. The poorest form of silicon is is quartz. And silicon can be found in feldspar, olivine, pyroxene. I think we mentioned that before. Okay. And last but by no means least, one anotropic form of silicon is the amorphous brown powder, which is found in dirty beach sand. So that's an overall of silicon here. And very quickly, let's look at silicon. So here we have it, silicon, right below carbon there. And there's germanium, which has competition with a faster moving electronic properties that give it some computing, some faster moving electronic devices. Germanium. So silicon, 14 germanium, with atomic number of 32. There is a silicon there for notes, and that's silicon from our car. All right.